first example, solve the system of equations algebraically. We have two equations. The first one is quadratic because we have here a power 2, and the second one is linear. So this is a quadratic function, and this is a linear function. And we need to solve them algebraically. Solve means find the value of x and the value of y, or the point of intersection, which is x and y. Okay, x and y that satisfies both equations together. Look at the first equation. We have y equals this, x squared minus 2x minus 3. The second equation is written in standard form of the linear function, which is x plus y equals 3. We will also need to write it as slope-intercept form to make only y isolated on the left-hand side. So in this case, it will be y equals, and I will subtract x from the other side to be 3 minus x. Now look at this equation and the first equation that I already have. So now I have y equals and y equals. Both of them are equal to y, so I will just write it as both equations equal to each other, because both of the equations are equal to y. So this means that x squared minus 2x minus 3, this is the first equation that is equal to y, equals the second equation, which is 3 minus x, that is also equal to y. I just remove the y because both of them have the same value, y. Okay, the second step is to put them all in standard form, okay, all on one side. So I will write it as x squared minus 2x minus 3, and this 3 minus x will move on the other side by changing their signs. It will be negative 3 and plus x equals 0. Now this is the quadratic function. Let us combine the like terms. I have negative 2x plus x, it's negative x, and negative 3 minus 3 is minus 6 equals 0. Now I have this. I can solve it either by factoring as x and x. This is negative, so this is here plus and minus, and the two numbers times each other is 6, and plus or negative each other is negative 1. This will be plus 2 and minus 3. From the first bracket, we know that x plus 2 equals 0. This is x equals negative 2. And from the second one, x equals positive 3. I have now two values for x. For each value of x, I will find its own y. So let us continue here. For x equals negative 2, let us find its y. So where can I find the y? I can substitute either in the first equation or the second equation. And I prefer the simplest one is the one which I wrote here in slope-intercept form. So y equals 3 minus x, and x is negative 2. This makes 3 plus 2 is 5. So the first point is at negative 2 and 5. This is the first point of intersection. For the second point, which is x equals 3, or the second value of x, x equals 3. Let us find its y. Y equals 3 minus x. That is 3 minus 3 equals 0. So the second point of intersection is at 3, which is x, and 0, that is y. So here we have the final solution. I got the 2 points of intersection between the straight line and the parabola. So the solutions are the 2 points of intersection. The first one is at negative 2 and 5, and the second one is at 3 and 0. Let us move to Desmos to check our answers and see this on the graph. So on Desmos, I'm going to write the equation as it is. It is y equals, the first one is y equals x squared minus 2x minus 3. So this is the first parabola. Can you see the first parabola here? Okay. The second equation, I will write it as it is also. It's x plus y equals 3, and this graphs this straight line. Now look at these two graphs, the line and the parabola. If you can see, they both of them meet at negative 2 and 5. The point of intersection is at negative 2 and 5, and the second point of intersection is at 3 and 0. And these are the exact numbers that we have got when we solved it algebraically. Now it's your turn to check your understanding. Please pause the video, try to solve this one, and come back to check your answer. Equation is given as y equals this, and the second equation is y equals 7. Again, both of them are y's. So I can just put that these two equations are equal together. So let us write it as 2x squared minus 3x plus 5 equals 7. Okay, now we have to write it in standard form. So we'll subtract 7 on the other side to make it 2x squared minus 3x plus 5 minus 7 equals 0. And combine the positive 5 and the negative 7 to make negative 2 equals 0. Now, I can solve this quadratic function to find x using either factoring or the quadratic formula. I prefer here to use the quadratic formula, which is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, it's always better to write what is a, b, and c before you start. So what is a? It is 2, and b is negative 3. Don't forget that there is negative. And c is negative 2. Okay, so this makes x equals negative 3 plus or minus square root of b squared, which is negative 3 power 2. And we said if you have a power 2, ignore the negative, just put positive 3 power 2 minus 4 times a times c. This is all under the square root and all over 2 times a, that is 2 times 2. When you do this on the calculator, one with the first time with positive and the second time with negative, you will get x1 equals 2, and the second x, which is x2, equals negative 0.5. Now to find the y, I'm going to get back to my original equations. I have the first y given as a quadratic function, and the second y is just a 7. And I know that y is the same for both. So this means y equals 7 for any x. So y is always 7, and here I did not do any calculation because it's a constant function, y equals 7, and I can write that the solutions for this system of equation is the first point, 2 and 7, and the second point is negative 0.5 and also 7. You can also check this on Desmos. It will draw two graphs. One of them is a straight line, the second one is a parabola, and both will intersect at 2 and 7 and negative 0.5 and 7.